everyone, this is a video on how to fix your portable AC unit for $13, believe it or not. This is a LG model LP0711WNRY2 model. It can be applied to most other models as well. So here goes. So I have this AC unit. The fan is running, but the compressor is not coming on. I changed the temperature, I lowered it, but it's not coming on. The compressor is not coming on. The fan is running, but the compressor is not coming on. So let's see what we can do with it. Of the unit, there are 11 screws on this model. So we'll have to just keep them in a safe place. At the end of the fix, we want to make sure we have every one of them back in the same place. Now, after we remove the screws from the back of the cover, slowly and carefully remove the back cover. Notice the black cable. That cable is the controller connection cable to the unit. So be careful not to overextend it and damage that cable. So gently put it to the side, and then we'll take it from there. Okay, so there's one additional screw in the front of the unit that, when removed, will release the side panels and you can see the entire unit. After that's removed, pull the front panel off and vacuum the entire unit. Vacuum it thoroughly, take a close look at it to see if there's any leak in the tubing. Don't be too afraid, get close to it. Get the vacuum in all the nooks and crannies as best you can without damaging the fins and the coils. Clean it as best you can, pull it apart, and go through while looking for any visible leaks in the copper coils. Anything out of the ordinary that may cause the unit to stop working. But don't go beyond that. Just clean as best you can, vacuum it thoroughly, and then we're going to try a restart on the unit just to see if the coils or dust or a clock filter or anything like that could have stopped it from working. And if that doesn't help the problem, we'll investigate a little further. So right now we're going to restart the unit and see what happens. So one other step before we restart, we want to check to make sure there's no water at the bottom. There's a float switch that will prevent it from starting. We've checked that there is no water at the bottom, and we restarted it. The fan still runs, but the compressor does not come on. So we're the same place where we started, and we'll continue troubleshooting. So one of the common problems of these units is that the capacitor for the compressor is gone. So we want to take a look at where that capacitor is. At the back of the unit, there's an electronics cover. It could be different in different units, but usually it's buried within the electronics cabinet. So in this unit, there is a silver panel at the back with a schematic right on it, as you can see, and this is what this unit looks like. So we're going to take it off and try to look a little further. Alright, so we just opened the back cover of the unit and the electronics board, and we're zooming right into where the capacitor is. The little circle, cylindrical shape at the bottom, that's your capacitor. You'll notice it has 3 terminals on this one here, and we'll dive in a little closer and see what's going on with it. So here goes. So this is the capacitor. There's one strap holding it at the bottom, one screw. You'll just remove that screw to get it out. But before we do that, we're going to identify the terminals with a little tape and take some photographs to make sure we know when we're putting it back what terminals go where if we have to. So again, take some pictures, remove that one strap, and we'll get that capacitor out of there. Alright, with the capacitor removed, we notice it's a 45 microfarad 250 volt capacitor. So we want to check that. The next step is to check it to make sure the value is good. So safety first. What's very, very important, we're going to check the voltage across the capacitor and discharge any residual voltage. Very important. So a quick and cheap way is to just get a pigtail socket, put it across the capacitor. If you don't have one, some people short it. I choose not to. I choose to put a bulb with some kind of load to just discharge that voltage, and then just verify that voltage with a multimeter. Make sure there's no volts across that capacitor. Sometimes the capacitor will hold a voltage which could be lethal. After verifying and re-verifying there's no voltage, then and only then do I start taking a screwdriver and prying the terminals of the capacitor. So slowly I pry one at a time until all three are off. The next step, with my multimeter in the capacitor mode, I checked a known capacitor value, and the meter shows exactly what the capacitor is stamped at, and everything is fine. So the meter is calibrated, and I'm satisfied with the reading. So now I check the capacitor we just took out, and it's showing 0.026 nanofarad, and it should be a 45 microfarad. This capacitor is shot, and this is possibly the reason why the compressor is not coming on. We're going to order one and see what happens. So I found a replacement on eBay, $13. Went ahead and ordered it. Came 3 days later, nicely packed. Took it out, verified that it's indeed what it is. It's a 45 microfarad, exactly what I'm looking for. And compared to the old one, slightly bigger, but have enough room to fit it in. Don't think there'll be an issue. So let's see. Verifying that it with the meter, and it says 46 microfarad, so it's within the tolerances. Everything should be fine. And we'll go ahead and install it. So using a needle nose, I squeezed the terminals in, connected it onto the new capacitor, just ensuring that they're in the same orientation as the old capacitor, and everything went smoothly. Before we continue, I think it's important to look at the schematic. If you look at the C1 upper left on the diagram, it's connected to the compressor. The compressor has power coming from the contactor. It then an S terminal via the red goes to the capacitor, and a blue terminal goes to the run part of the compressor. If you take a closer look, you'll see what I'm talking about. The S goes to the red, that's the start, and the run contactor goes to the blue terminal on C1. The blue is connected to the neutral, so the capacitor is acting as a neutral return for the compressor. So a little schematic of what's happening within the compressor. In our case, the start capacitor will drop out about 70 to 80% of the speed of the compressor, at which case after that start capacitor drops out, it goes across the line. Alright, so we get all the screws together, put on back the back cover, the electronics cover, making sure to put the right screws in the right place. Screw on the back cover, and then we're going to screw on the back plate, the sides of the unit. Make sure the unit is the way we found it. Careful with the extension cable from the controller to the unit. Make sure we don't squeeze it. Turn the unit on. Increase the temperature. And the compressor just came on. It works. There you go, folks. You've just fixed your portable AC. All you need is a multimeter, a screwdriver, and some patience, but most importantly, perseverance. With perseverance, you can solve almost any problems you have. Thank you. Just recapping why the capacitor is needed in this application and in most applications. The capacitor is used to create a multi-phase power supply from a single phase voltage source. And in this curve will show the difference in the effects of capacitance on the speed-torque curve of the motor. And finally, if we want to rotate a motor in different directions, how we actually can connect it the induction motors that have counterclockwise or clockwise rotation. Just remember, persistent, persistent, persistent. If you just persevere, you can get it done. Take care.